party barge, floating bridge, luxury raft. Just some of the many functions of pontoon boats. While their basic design hasn't changed much over the years, new materials have made pontoons bigger, sleeker, sturdier, and faster. And what better way to enjoy an afternoon than on the lake? In the old days, pontoons floated atop 45-gallon steel drums. Today, they ride on custom-built floating chambers made of special aluminum alloy. These floating chambers start off as sheets of aluminum. This rolling machine forms them into tubes, applying pressure equivalent to the weight of 26 elephants. A worker slides each cylinder onto a track to stabilize it for welding. A pacing machine regulates the speed of the welding torch so that it connects the tube's edges evenly, producing a solid watertight seal. Meanwhile, this rolling machine shapes aluminum sheets into tapered cylinders called nose cones. By varying the hydraulic pressure, the operator is able to mold the aluminum into the shape of a large cone. They use a special aluminum alloy to make the chambers shockproof. Next step, making this pontoon leak-proof. First, the welder clamps the nose cone seams together to prepare for welding. Because of its unique shape, the nose cone has to be welded completely by hand. This type of welding, called TIG welding, generates temperatures that can reach 9,000 degrees Fahrenheit. The nose cones will sit at the bow of the boat in front of the other floating chambers. The waffled component at the end of each chamber is called a baffle. It adds extra protection against leaks. This hydraulic press squeezes the sections together for an extra snug fit. Chambers are welded together to form floats. The number of chambers per float varies depending on the pontoon's length. These risers will hold the pontoon's floor in place. Each chamber floats on its own, so even with several punctures, the boat would stay afloat. A worker shoots compressed air into each chamber to check for leaks. He coats the welds with a soapy solution, which will bubble up in the case of an air leak. This demonstration shows that if air can get out through this tiny hole, then water can get in through it. Workers install aluminum cross members to support all the weight that will be added on top. A pneumatic torque wrench is used to bolt the cross members into the risers with rust-proof nuts. Next, the boat's floor is constructed from sheets of pressure-treated plywood. Pop rivets anchor it securely to the cross members. Workers custom cut and glue down a marine carpet. It's made of plastic, so even with a lot of water exposure, it still won't rot. Now for some fade-resistant decals. Rollers crimp the boat's aluminum side panels to make them stronger. Corrugated panels don't warp or wobble as much as flat ones. Using a pop rivet gun, a worker fastens the panels onto the railing. This shaping machine curves the railing in all the right places, bending the malleable metal with varying pressure. Next, workers bring the assembled pieces to the platform. Screws and bolts secure everything to the boat's floor, including the furniture. The pontoon's captain will command the craft using this console. The buttons for the horn, lights, and music sit at the top of the console for easy access. Extra touches bring some of the comforts of home to this craft. Wires and control cables connect the captain's console to this 50-horsepower motor. It's by no means a high-speed engine, but it gives a pontoon boat all the power it needs for a leisurely spin on the lake.
How and when the first pretzel came to be depends on whom you ask. One story tells of a monk baking rewards for children who were pious. Today's bakeries still fold the dough to resemble arms crossed in prayer. But they do it much faster, granting tasty wishes to a lot more snackers. Although hard pretzels are more common, this company makes the more traditional soft-baked ones. To make enough dough for 4,870 pretzels, a worker first blends shortening, sugar, and salt in a huge mixer. The machine automatically adds yeast, corn syrup, 1,630 gallons of cold water, and 760 pounds of flour. The cold water helps make the dough elastic, so workers can shape it before it hardens. The worker then opens the mixer and slows the blades to help the dough fall out. He splits the batch on a table, then creates chunks that go into a tank called a hopper. It feeds an auger that channels the dough chunks through little guillotines. The blades chop the chunks into 2.5-ounce balls to make small pretzels, or 5-ounce balls for large pretzels. 2 conveyor belts squeeze them into 15.5-inch long segments called noodles. Another machine now grabs the ends of each noodle and twists the ends over each other to create the pretzel's 3 signature holes. To keep this knot from unraveling, the plate then gently flips the pretzel dough onto another plate below. That plate carefully flips the doughy creations onto a 118-foot-long conveyor belt. The raw pretzels now travel on the conveyor for 14 minutes, the time it takes for the dough to rise. Next, they move through showers of liquid sodium hydroxide heated to 180 degrees Fahrenheit. That seals in the moisture, so the pretzel will be chewy when you eat it. They go into an oven that's about the length of a city bus. As they enter, flames sear and harden the outside. This prevents the bottoms from sticking to the mesh conveyor belt during baking. After about 3.5 minutes at 560 degrees Fahrenheit, the pretzels are piping hot and golden brown. They drop onto a long conveyor where they gradually cool on their way to the next step, a trip through a freezer that's longer than 7 Olympic-sized swimming pools. After 30 minutes at minus 28 degrees Celsius, the pretzels are rock solid and ready for packaging. But first, a camera scans them so that a computer can track each pretzel and guide a robotic arm to pick it up. This arm is one of 5 operating at separate points on the line. The robots process 1 pretzel per second and clean up after each other until the belt is picked clean. The pretzels then fall through a sliding gate, landing on a conveyor that whisks them off to the next step. There, a machine drops a packet of coarse salt into each bin of 6 pretzels. A mechanical arm nudges the pretzels over to make room for it. The salt packet lets you season your pretzel the traditional way before warming it up at home. The machine blows open plastic bags with compressed air. Mechanical arms push the pretzels and salt packet inside. A robot arm then places each bag into a cardboard box. The printing on this package displays the company logo, the nutritional content, the production date, and the heating instructions. So, next time you're looking for a salty snack, don't tie yourself up in knots. Just have a pretzel instead. Golf players in 17th century Scotland were the first to hone their game by using differently shaped clubs for specific tasks. Today, you use what's called a putter to gently roll the ball into the hole, using the fewest number of strokes. The club's high-tech, streamlined design is crucial to any golfer's putting strategy. This company uses a robotic tester to spot-check its putters for quality. The club passes if the balls roll along a straight line into the hole. That means the putter's striking with just the right impact. Production begins with bars of aluminum, a metal that's lightweight and easy to sculpt. A bandsaw slices them into 4.5-inch long pieces. Each piece will become a putter head, the part of the club that hits the ball. A computer-guided cutting tool sculpts the heads by shaving away up to a third of the aluminum. The machine first mills one side of the head into tiny steps. Another cutting tool then shapes this area into a smooth curve. The process takes 10 minutes. Then the four-sided platform revolves and the cutter begins working on the next putter head. Another milling machine carves blocks of copper-nickel alloy into what's called the insert. This part will fit into a cavity in the putter head, making the area that strikes the ball firm, yet resonant. It's why the golfer feels the impact reverberate through the putter, what's known as feedback. This device performs random quality checks of the insert cavities in the putter heads. A vise holds the head as the probe gauges the cavity's width and depth. Next, these chunks of copper go into a chemical bath with putter head models made of different metals. The material from which a putter head's made determines the weight and feel of the club. This 10-minute bath removes any contaminants from the surface of the metals and coats the heads in copper. This ensures that the plating they're going to get will stick. After that, the heads are plated in a different metal. This determines how the club looks. For this, chunks of matte-finished nickel go into a second chemical bath. They'll provide one of this company's 4 finishes, ranging from matte to shiny. During this 15-minute step, a mechanical arm occasionally shifts the rack to disperse the chemicals and thoroughly plate the heads. To fit the insert, a worker first positions the head in a vise. He applies 4 drops of epoxy glue inside the rim of the insert cavity. This provides additional bonding once they force the insert all the way in. After placing the insert in the cavity by hand, a worker uses a press to force it inside. They cover the press with paper so it won't scratch the insert, which must be flush with the surface of the head. Any air under the insert escapes through a hole underneath, where they'll insert the club shaft. A worker first applies glue inside the hole. Then he inserts the shaft and secures it to a template with rubber bands. The shaft is made of stainless steel. They usually come in standard lengths of 33, 34, and 35 inches. They're set at the angle most players prefer, 18 degrees. The next step is to mount a hand grip at the top of the shaft. First, a worker wraps the top in double-sided tape. Then he pours water over the tape to dilute the glue on its surface. This will enable the grip to slide on more easily. He pours water inside the grip as well. The grip is a rubber sleeve that's just under 10 inches long. Once lubricated, it shimmies over the shaft for a snug fit that lasts up to 3 years. He lines up the flat part of the grip at a 90-degree angle with the flat part of the putter head. This helps the player strike the ball properly. Next, a worker colors the club's engraved logo. Using a tiny nozzle, she applies minute amounts of epoxy paint inside the grooves of the design. She controls the amount of paint with the foot pedal that releases pressurized air into the nozzle. This company makes putter heads in some fairly luxurious materials, including beryllium copper. That's one for players wanting a club with a softer feel and who don't mind paying up to $500 to get it.
Kart racing is an international motorsport that has a huge following, especially in Europe. The karts look a bit like miniature Formula One race cars, but have no suspension system. Kart racing can be even more exciting than F1 because of their small size and increased maneuverability. This Italian-made racing kart with its one-cylinder 125cc engine reaches speeds of 110 miles per hour. An aluminum case houses all the engine components. A computer-guided drill bores various holes for installing them. First in, the engine's 6 steel gears. Each gear is actually comprised of several gears. They thread them onto a shaft. Then everything goes into the gearbox. Behind the gears goes the gear shifter, which the driver operates with a lever. Next comes the drive shaft. It turns a chain that rotates the axle on which the rear wheels are mounted. On the other side of the engine case, they install the drive shaft gears. These ensure the shaft rotates at a stable and controlled rate. The red markings help the technicians align the gears. The clutch cover closes up the gearbox. The clutch's main housing, called the drum, contains the clutch discs. These discs transmit crankshaft motion to the gearbox, which turns the drive shaft, which moves the chain that rotates the rear wheels. Thick steel springs grip and release the clutch discs. This flapped component, called the lamellae pack, controls how much fuel enters the engine. Stepping on the acceleration pedal creates a vacuum that opens the flaps and sucks in more fuel. The cylinder houses the piston that rotates the crankshaft. This engine head seals the cylinder in which the combustion cycle occurs. The ignition goes on the left side of the engine. The engine is now finished and ready for a bench test. Technicians use special instruments to monitor and calibrate its performance. The racing kart's chassis is made of steel tubing. At the back, they mount bearings to hold the rear axle. Then they mount the axle itself, and on it, brake discs. They attach brake calipers to the chassis. Under braking, they squeeze the discs to stop the wheels from turning. After measuring again to ensure the rear axle is perfectly centered, they lock it in position in a way that enables it to rotate, of course. Now for the steering system. At the front of the chassis, technicians mount a spindle on each side. The spindles turn the kart's front wheels. Once technicians fasten the steering column up top, they connect tie rods to the spindles. Tie rods transmit the rotation of the steering column via those spindles to the front wheels. Next, technicians mount 2 spring-loaded pedals in front of the chassis. The brake system is hydraulic, meaning that pressurized fluid activates the calipers to grab or release the brake discs. Next come the wheel hubs, on which the tire rims go. Then the engine, followed by the tires. And a fiberglass driver's seat, which due to the lack of suspension, lets the driver feel every inch of the track. Finally, the steering wheel and a data recording device that tracks everything from speed and lap time to tire and exhaust temperatures.
The first reclining armchair was introduced by the Lazy Boy Company in 1928. Today, many companies make motion furniture, as the industry calls it. And the term recliner no longer refers to just armchairs. You can buy reclining couches and even reclining sectionals. This factory makes reclining chairs and couches in both fabric and leather. The furniture construction is the same, regardless of the material, but leather upholstering requires a few extra steps. They begin by inspecting the hide, marking serious defects with one color of tape and minor imperfections with another. A computer-programmed cutting machine scans and registers the tape markings, then automatically cuts and discards the defective parts. It cuts upholstery pieces for hidden areas, such as the undersides of seat cushions, from the imperfect leather, and visible parts from flawless leather. Once all the pieces are cut, they sew together the back, seat, and arms. Then they stuff the arms and back. They position the open end against a blowing machine that fills it with polyester fiber. Workers weigh each part before and after filling. This ensures they've blown in the right amount of fiber and that both arms have equal fill-in. Next, they'll fill the seat with foam. A compression machine squeezes it, then a worker sprays on silicone lubricant. This enables the seat cover to slide on easily. Foam is made of a chemical mixture, the formulation of which determines the density. The higher the density, the higher the quality. Elsewhere in the factory, they cut the frame components from plywood using a computer-guided bandsaw. These long pieces will form the seat frame. A three-seater couch has three separate frames, enabling each seat to recline individually. A machine lines one side of each piece with steel spring clips. A worker then dabs the ends in glue and assembles the pieces, reinforcing them with long glue-coated staples. As the staples enter the wood, friction-generated heat melts the glue. The glue then dries, securing the staples. Now comes the step known as springing the seat. They hook 5 thick steel springs into the spring clips, then hammer the clips closed to lock the springs in place. They connect the springs with a plastic-covered wire so that when you sit on the seat, all the springs react in unison. They assemble the frame pieces for the arm using glue and glue-coated staples, plus a few screws at strategic points. They screw the arm to the seat and begin upholstering. First, a layer of felt to cushion the springs, then wood, cardboard, and foam to form the rounded shape of the armrest. After lubricating with silicone spray, they slip on the leather and staple it in place. They upholster the backrest and sides in the same manner. The reclining mechanism arrives at the factory with the sides pre-assembled. Workers install the connecting pieces, then a bushing that reduces the noise the mechanism makes. Finally, they install a spring to control the recline speed. They screw the mechanism to the seat frame. Then hook up the operating handle and test it out. To cover the back of the furniture, they attach metal tacking strips to the leather. Then turn the edge under and hammer the tacks into the frame using a pneumatic hammer. The last step is to attach the back to the seat. There's a detachable flap at the bottom, providing access to a locking spring inside. The locking spring lets you remove the back if you have trouble getting the furniture through a doorway. At this factory, workers are encouraged to lie down on the job, but only to inspect the furniture. After examining the fabric and sewing, they assess the comfort and test the reclining motion. Talk about a cushy job.